either class, either the myQ or the stack class.
How are you supposed to declare which object?
In the case of either stack or either the stack or the queue,
Mm-hmm.
how do you like define? Do you define the object in the or like?
Do you define which object? Which object are you asking about? Suppose we're talking about the stack class. You're asking how do you define the object. My question is, what object?
Like like the linked list because
Ah, okay.
we're calling like my stack equals new my stack in
So,
the main class, and I'm just not sure what I'm supposed to do in the constructor.
all right. So, let me turn on my screen share. So I'll demungle the ODP after class is over at 12. So ODP 302 doesn't work right now. I'll fix it in a couple of hours.
Oh,
So is it still due today then, I'm assuming? Or?
It's due Friday morning at 8. So
Oh, it is? Oh,
yeah.
okay. Was there an ODP due yesterday?
There was an ODP due this morning at 8. These are 2-day programs.
Damn it, son of a gun.
It's the ODP that was given out Monday, so
Yeah,
it wasn't a new one.
Last Monday I had no power.
well, because the snow wasn't.
Yeah, I've had snow here 3 days in a row now.
Oh, okay. Well, send me an email and let me know that.
No, it's fine. I should have known it was due at 8. I forgot they were due at 8, not midnight.
Well, send me an email anyway.
Hmm.
So here's the class MyStack, right? So you're gonna have a constructor.
Nick, really quick, are you recording or not?
I am recording.
Okay.
Your screen went black, like your recording of your face.
Yeah, I turned that camera off because it was bugging me.
Oh, I see.
Let me throw on my record notice here. So you're gonna have your constructor, which is public MyStack, and it doesn't need any arguments. All right, but inside the class itself is where we want to define our linked list. And so somewhere inside here, but outside of our methods, you're going to want to say linked list angle bracket integer. And what do you want to call your linked list? I'm just going to call it stack. Okay, this is the linked list that's going to hold the integers that represent our stack. And so I'm declaring it up here so it's available, anywhere inside this class. And I'm going to construct it inside the constructor for the MyStack. So inside my constructor, all I'm going to have to say is stack equals new linked list. All right, so what have we got here? This is the whole class definition, right, from here to here. Inside the class, there's an object named stack, which is a linked list. It's declared, but it's not constructed yet. It doesn't. It's null, right? It doesn't actually point to anything. But when you in your main program say, my stack s equals new my stack, that's going to call the constructor. What's the constructor going to do? It's going to construct a new linked list and set this object stack equal to that. And so down here in my isEmpty method, I'm going to say, hey, let's check if stack is empty. So I'll call stack.isEmpty and return that as the value for the isEmpty method for the class MyStack. So there's multiple levels going on here, but does that make more sense?
Yeah.
Okay.
Makes more sense.
Cool. All right.
Are there any other topics that we haven't covered that pertain to the A1 meeting that we can talk about?
No, you should have everything you need. But if there's anything that's confusing, we can definitely talk about that now, because,
Okay.
as I've said, it's not that complex of a program in terms of number of moving parts, but where to put things like this is where the whole challenge is. So we can definitely talk about stuff. Yeah.
I'm assuming on Monday you talked about error checking for the numbers.
Mm-hmm.
Yes.
Okay. All right. I'll check that video.
Yeah. So the key there is to use try-catch blocks. And when you do integer.parseInt, we put that inside what's called a try block. So we say try curly brackets, and we put our potentially hazardous statement inside there. And then we have what's called a catch block after this. And if this statement fails, instead of exiting the program, it will jump down to our catch block. And so, yeah, the mechanics of that are in the lecture, and there's also some sample code that that shows you ways to do that. And it's really just kind of adding a few of these statements, just a try statement and a catch statement around what you already have.
I see. Okay, cool. Thank you.
Yeah, you're welcome. Alright, let me hop onto Canvas for 1 second. How many times do I have to log in one morning? We're up to 3. Alright, I'm going to send an announcement for the second section of 250. That's the Tuesday-Thursday one, saying that the ODP will be fixed in a few hours. I'm not going to send an announcement here because everybody is here right now, and so I'll tell you right now, ODP 302 has got a bug, and I'll fix it after 12.
So can you remember what ODP 302 is?
Yeah, so we'll talk about the ODP. I also want to review ODP 301 and see if people ran into any issues with that. So let's review ODP 301 first. So 301, you were writing this class called myClass that you construct with an integer argument, and it should save that integer into a variable in the class called x. And that's all that your class had to do. And then you can test it by accessing your object name.x or manipulating object name.x. And so one way to do that is like this. So there's a class declaration, here's the integer x, here's the constructor, and the constructor just says this dot x equals x. It did not have to do that. Let's get rid of this keyword. So here's a good solution for ODP 301. So there's a constructor, it takes an integer called arg, and we just save that into x.
Someone has their mic unmuted.
Oh, sorry.
That's okay.
You're good.
Chat window. All right, so that's all you needed for 301. So ODP 302, same basic setup. You're going to have a class called myClass, but in this case, I want x to be private. And so if you try to do something like mc.x equals 17 or print mc.x, you're going to get a compile error. So x is going to be a private int, but you're going to make a pair of methods. One is called int getX, and that returns the value of x, and the other is called void setX, which takes an integer argument, and that sets x equal to the value that you pass to it. So this is an accessor and a mutator, or a getter and a setter. So exactly the same class you had, but with these methods to give you access to x.
Can you give me a review on like what the differences are between the accessor and a mutator?
Accessors are for getting the variable, mutators are for changing the variable.
Okay.
So to get the variable, we don't pass an argument, we just say get x and it returns an int. To change the value of x, we don't need a return value, but we pass the value we want x to be equal to this method called setX. And this can be declared void because it doesn't return anything. It just takes this argument, sets x equal to it. So you can take your my class from ODP 301, change x to be private, and then write a pair of methods, getX and setX. Make those methods public, and then you should be good to go.
So I got a question though.
Sure.
So it says to it says you still want to do a constructor that accepts an integer argument and saves it in a public variable called x.
Private variable.
Okay. How would we structure the constructor? Oh wait.
But x should be a private variable. So.
In the constructor, would we use setX initially?
You could, or you could just say x equals, because even though it's private, everything in your class has access to that variable.
Oh yeah, that's true.
So you could use setX, and in fact, that's a common thing to do, is to use the accessor or mutator inside the class itself. All right, and I fixed that typo. All right, so clear on 302. And you assess it like this. And if you try to do that right now, you get it throwing up on your screen.
Nice.
Hey, maybe I just fixed it. Alright, so I think it should work now. We'll see. It's been a quarter since we did ODP, so I've only done a few Java ODPs, and that was a few years ago. So I'm a little rusty on how to set those up, but we'll figure it out. All right, other questions? Either on ODPs or on PA1B or anything else. All right, let's try something. Let's talk about. Oh, that's why my machine is so slow. Yeah, it's our Minecraft server.
Oh, really?
Yeah.
For who?
Just for the house.
That's awesome.
Yeah. So Mara, my 9-year-old, I gave her a laptop that I had from like years ago, and it's got Linux on it. She's been playing Minecraft on that, and it's just such a slow, pokey machine. So broke down and bought a desktop system, and now we can run resource packs and all kinds of good stuff. So, and I've gotten like totally sucked back into Minecraft. So
That'll happen.
yeah, it will. And I never played survival mode before. I always did creative, and survival was just kind of like, nah, not really interested. But with like multiple people, survival mode is really fun.
Oh yeah.
Because
I've
yeah,
got over a week of playing time on some servers with buddies.
yeah, it's good stuff. Yeah, I'm a big fan of Minecraft because and I mean, you can teach coding through Minecraft, and there's actually some good books on how to do that through Python and such. And I mean, it's the whole idea of coding is to like take your problem, break it down into small pieces, tackle those small pieces, put them together to make the big solution. That's Minecraft, you know. You got your hands in some trees, and you just build up from there. So I kind of wish we could like do a Minecraft course as like a prereq.
That's one prereq I wouldn't mind.
Wouldn't that be cool?
We could maybe replace physics with that one.
That's an idea, yeah.
Physics 3 maybe even?
Yeah, we could have 3 Minecraft courses.
Please. Please, yes. Please,
Yeah,
yes.
please.
Yeah, I should have done that on April 1st. Published a new catalog.
Bruh.
I remember using Minecraft as a way to kind of demonstrate digital logic.
Yeah,
Remember that?
yeah, totally.
That was pretty cool.
Yeah. Yeah, that's the other thing when you start playing with redstone and stuff. I mean, you can actually do all of the 250 stuff. It's pretty cool.
Probably would have ran faster than Tinkercad.
Yeah, right?
My final project in 250, I don't know if you remember, I had a video of it, and it took like seconds.
Yeah.
Render changes.
Mm-hmm.
Or
Was that the yellow traffic light one?
yeah.
Yeah.
It had red, yellow, green, and 4 different lights. And, well,
Yeah, I turned that in. I think I wired it correctly, but I could never get the simulation to run, so I just turned in what I have without testing it. I think I did okay.
Yeah, I remember a few cases where things looked perfect and there was some kind of glitch. Which might just be something, you know, that we didn't understand about how to use the tool, or it could be a glitch in the tool itself.
I would wait for a minute, and then the simulation would advance by 1 second.
Right.
So it was just like impossible.
Yeah. Let's see, what's the best way to import libs in Java? Just go ahead and write your import statements. And yeah, I mean, for a while we'll be using scanners and print writers and linked lists a lot, and maybe hash maps, and so you'll get good at knowing, you know, it's where those things come from. But yeah, it's okay to just kind of like, you know, copy your old code, delete everything you don't need, and just start from there. Same with the public static void main and so on. And as I've said, you know, IDEs will do this for you eventually. But for now, it's just becomes kind of a mantra you do when you want to start a Java program. You always say import this and public static void main that and so on. Alright, so in that vein, let me go ahead and make a class main. And our favorite public static void main. And did the user say hello? So we're going to write this Java program. We're going to run it with one command line argument. And our code is going to try to see if the person typed hello as their command line argument. So we're going to say Java main and then some word. So first thing I'm going to do before I check args bracket 0, I'm going to check to see if there was an argument, right? And if there wasn't, if the length of the command line argument array is not exactly 1, I'm going to, you know, come in here and say one thing, please. So if they type too many things or not enough things, we'll just error out. And now I'm going to say, you know, did they say hello? And I'm going to do this the incorrect way. By using double equal sign. And so there's our attempt at a simple conversational program.
Does double equal sign work? I thought you had to use equal.
Double equal sign does not work, so this is just a long-winded demonstration of that fact. I'm hoping it does not work, otherwise. So if I say Java main hello, it does not do what it's supposed to do. If I do Java main, this works. It says say one thing please. If I say Java main, this is fun, that's too many things, it'll say one thing please. But even when I say hello, it doesn't seem to work, right? And so what's going on here? Equal equal is not the way to compare strings. So let's comment that out. And args bracket 0 is a string. Args is an array of strings. Args bracket 0 is a particular string. Strings include an equals method. Equals takes a string argument and it returns a boolean to tell you whether or not the argument is equal to the string itself. So yeah, correct prediction from chat, false because they are not the same object. So if args bracket 0 equals hello, then we'll go ahead and we'll say hello to you too. Compile this, run this, says hello to you too. Alright, so this is why we have to use the equals method. But let's just wrinkle this up a little. And try this. And this double equal sign does work. If hello equals hello, let's print out hello to you too. And if hello equals this mangled string, right, it knows that those are not equal. So equal equal sometimes does look like it works, but it's a fool's gold, right? This is not comparing HELLO to HELLO. This is saying, is this object the same as this object? Well, it turns out in my program, when I have a string inside double quotes that represents an object of type string, the JVM basically creates that object for me. If at another point I have a string in double quotes with the same patterns, it does not create a second object. It uses this first object that was already created. So in this case, this object and this object are exactly the same object. They're the same location in memory, they're the same structure, and so the double equal returns, you know, true. But that's just kind of a happy coincidence. And if I actually use, you know, arg0 and HELLO, those are different objects. And so equal equal fails. So, don't be fooled by the fact that this seems to work. Do it like this. Alright, this may save you some heartache on future programming assignments. So if I say is 1 equal to 1, that's a different story. Because these are primitives, they're not objects. They're things of type int, which is a primitive. It's this sort of like, you know, second class object that just has a value, like an int or a char or a boolean with a lowercase b. And for those, we can use double equal signs. We want to use double equal signs. If you have expression and you want to know if it's equal to some other expression, we use double equal signs. But for objects, we can't do that. And so we need to remember that things like strings or an uppercase integer or uppercase boolean, these are objects, and they need to be treated as such. And most often this comes up with strings.
I think I remember you said in the beginning class where everything's an object, basically.
Pretty much, with the exception of primitives.
Okay, it's like a whole different rule of computer science for me, where now
Yeah.
we're looking at everything as an object instead of like, you know, just saying whether it's a string or integer.
Right.
I mean, except and you said integers are not objects; they're just numbers.
So if I say int I, that's not actually an object. It's called a primitive. And so if we try to do I dot equals, I'm pretty sure we'll get a compile error. But we don't have to because we can do double equal for primitives. All right, good.
Question.
Yeah.
If you did R0 toString and then did the double equal sign, would that work?
Still not the same object. So arg0 toString is going to return the string. It's going to return a string. In fact, let's try something kind of quirky. Let me leave this code intact and let's see if we can break something else. I don't know if this is going to print or not. This will be interesting. Oh, it does. Okay. So it's fairly smart about knowing that this is the string hello.
You didn't give an argument. You said the first thing.
Yeah, that's. Oh yeah. Okay. Thank you. Yeah, so it's pretty clever about knowing that when it converts this thing to a string, it's just HELLO, and it's still using the same argument here. So let's try this. Wow, okay, that's good. We could go down this rabbit hole.
Earlier I was saying if it's 1 equals to 1, I was saying like, is it always true that you're just comparing two of the same objects? Because otherwise if you return true regardless of the way you put it, incorrect.
So if you compare two of the same object explicitly, it should always come out to be true. Yeah, I can think of some other. So let's just do something a little weird. So strings come with, for example, a to uppercase method, right, which will convert a string to uppercase. So if I do quote hello dot to uppercase and see if that's equal to uppercase hello. Let's see if this works. All right, there we go. So hello dot to uppercase should be HELLO, but the equal fails. And it fails because to uppercase is a method that returns a string. So this method is going to construct a new object of type string and set it equal to the uppercase version of this. The contents of that object is HELLO, but it's a different object. And so this is not equal to that. But I could do this. Right, I can say if hello dot to uppercase dot equals uppercase hello, let's print out these are, equals paren. And so that matches successfully. So moral of the story is, if you want to compare two strings character by character, use the equals method. If you want to know if two objects are exactly the same object, that's the only time you use equal. No primitives in Ruby. That's interesting.
This runs on Ruby.
Say again.
The canvas runs on Ruby.
Does it?
Specifically Ruby on Rails.
Ruby on Rails, yeah.
I guess is
So equal.
back end.
Sorry, I'm gonna interrupt you there.
So it's they're back.
Cool.
Okay. I was saying that, so I'm trying to take notes here that two equal signs compares objects.
Mm-hmm.
And even like, and we just kind of understand that like what looks like a string could be considered an object.
Mm-hmm.
And equals is comparing the string itself, like the characters. Is it comparing technically the characters of the string?
Exactly. It's like string compare in C. It compares the length of the strings and it compares character by character. And if everything matches, then it returns true.
Okay. I was wondering if you could just kind of understand that double equals, it treats hello as a object. So can you kind of go into a little more detail about why it treats like an object, or where kind of the logic behind it?
Well, everything is an object, and you can see that here by the fact that I can call the to uppercase method on double quote hello. Right? The only way that it makes sense that this even compiles is if this thing before the period is an object, particularly an object of type string. So this is an instance of the string class, which means I can access its to uppercase method. And what does to uppercase return? It returns a string, which means this thing is an object of type string, and objects of type string come with an equals method. So what I'm doing here is taking hello, converting it to uppercase, and then seeing if the result is equal to this string. And this tacking together of things from left to right with dots to invoke methods or fields in classes, this is something pretty typical, and it's a little bit on par with when we use the arrow notation for trees and such, and we say, temp, arrow left, arrow right, arrow data. Same idea.
I'm kind of curious to know, is there arrow notation in Java, or is that just a C thing?
That's just a C thing. We don't need it. Basically, we're doing what we did with arrows with just plain old dots.
Okay.
And all of these objects are basically references to objects. So it's kind of like we're always using, star something dot. We're dereferencing a pointer. And so the pathways in our brains that we wired up to be able to do those arrow notations, right? That will help us, write things like this. And this becomes second nature, just thinking of everything as an object, and as soon as you have an object, you can access fields and methods from that. And equals returns a Boolean, so anything I can do with a Boolean, I can do with this, including, putting it inside an if statement.
Would it be weird to kind of put a method that returns a string after the Boolean?
So if I tried to do a dot something here that goes with something other than a Boolean, that will give me a compile error. And the error is I've got a Boolean and I can't access a field from it. This is actually a lowercase Boolean. So this is actually a primitive. It doesn't have, any methods at all associated with it. So if you look at the string documentation again, it's got an equals method, and the equals method returns a lowercase Boolean. So it's not actually returning an object at all, it's returning a primitive. And primitives, you can't say, primitive dot something. It's like trying to say integer I and then saying I dot something. And the giveaway here is, it says Boolean cannot be dereferenced. It's trying to do, this thing arrow equals. It's trying to dereference that reference to a Boolean, and that's not legit. So yeah, it's kind of a fun.
I was kind of curious based off of how many methods can you call for one statement?
Pretty much no limit. I mean, long as it logically makes sense, you can embed these things and string them out as much as you want, and it will handle it just fine. I mean, there's a limit of a billion or something, but effectively no limit.
Okay.
And sometimes this is a great thing to do, right? I mean, if you understand the methods for a string class, here's a string, I'm converting it to uppercase, I'm seeing if it's equal to something. No confusion there, right? But sometimes, it might make sense to take something like, part of this and save it in a string and then do something with that string in a separate statement. So that's coding style question. That's how much you want your code to be easily readable versus, the word I can't say, obfuscated. I can't pronounce that. Made deliberately confusing. Alright, we're going in. Let's talk about statics. I said I wasn't going to talk about them for a few weeks, but I'm going to talk about them today. Because why not? Alright, so I'm going to use doubles. Doubles are another type of primitive. It's just a double precision floating point number, same as C. So I'm going to set x equal to the value 2. And I want to take the square root of 2 and print that out. And then I'm going to say All right, so how do we calculate square roots in Java? There's a class called math, and math includes a bunch of methods: absolute, arc cosine, add exact, arc sine, etc., etc. It's got all these methods in it. One of the methods is called square root. It takes a double, it returns a double. Guess what? It says it's static. All right, so we have this class called math. Somebody wrote all these methods for doing things like calculating the square root of something. And to calculate the square root, you use some algorithm. You use Newton's approximation or something like that. Or you add, you know, Taylor series. But you do some work. There's a bunch of Java code that that will ultimately take, you know, a double in this case and return the square root. All right. And the code is contained in this method named square root, which is sitting in this class called math. All right, well, we've said that, you know, to run a method from a class, you take an object of that type and you say object name dot method. Well, I want to calculate the square root of 2, but I don't have a math object. So let's not do this, but we could do this. I could construct a math object, and then I could say m dot square root of x. All right, I create an object. Sorry?
You also gotta import it on top, right?
I don't think we need to import it. It's part of Java language.
Oh, okay.
Yeah. Otherwise, yeah, we would. All right, so I'm making an object of type math, and then that object I can say go ahead and call the square root method. But this is goofy, right? I don't want a math object. All I want is the square root method. And if I had to do this, this would be kind of inconvenient. I would have to create this object, which, you know, takes all of this memory allocation and all of this housekeeping and garbage collection later and so on and so forth. And I don't really want an object of type math. All I want is this little piece of code inside the math class. So in theory, I could do it like this. I'll get at least warnings. I might actually get compile errors, but I'm just kind of curious. Yeah, so I can't actually do this, right? But this would be a goofy thing to do, so let me comment this out. Instead, do this. Alright, so we do something really strange here. Instead of putting in the name of an object, I put in the name of the class itself. This looks very much like this, except up here, and every time we've done this so far, I've had the name of an object, followed by a period, followed by a method from that object's class. But here what I'm doing is I'm actually using the name of the class itself. I'm not constructing a math object, right? So yes, I'm not instantiating an object of type math. I'm saying, hey, look inside the math class for a method named square root. That's what I want to run. Go ahead and run that code. And we'll set y equal to that. And so if we compile this and we run it, we get our beautiful square root of 2. All right, so when we do this, when we say the name of the class dot method, that's what's called a static method inside this class. And so the square root package, the square root method inside math is defined as a static. Static means you're not going to invoke this as a method inside an object. You're going to invoke it as part of the class itself. So if you have a static method, you say class name dot method. So let's put these side by side. So non-static method. Non-static method, we construct an object of some class, of some type, class name, and then we can say that object name dot method. And it runs that method kind of like inside this object. With statics, we can just say the class name itself dot method. So far, we have not done something like this. The methods we've written so far, you know, for PA1B, those are methods that you invoke with some sort of object, with stack dot is empty, with q dot add element, or things like that, right? So the methods we're writing so far are not static methods. These are actually called instance methods. They're methods that we execute based on some instance of our class. Static methods are sometimes called class methods. And they're methods that we invoke using the class itself. The difference is when this method is running, there is no object of type class name. And so if we made our rectangle class and we had a static method in there, when that method is executing, there is no height and no width that it can access. Because the height and the width are elements of objects of type rectangle. So most everything we've done, most everything we're going to do for most of this course, we're going to be dealing with instance methods, and we're not going to be using the keyword static, except for public static void main.
What's the danger of using a static method?
If I make a static method and I try to access a field inside my class, I'll get compiler errors. For example, let me write this instead of type it, because this is bad. So here's our class rectangle. And I've got integer height and width. And suppose I make a static integer area. And I say return height times width. Alright, this will give me compile errors. And the compiler error will say attempt to reference non-static variable from static context. In other words, when I say something like, you know, uppercase rectangle, the class name dot area. So in my main program I try to do this. Well, I'm going to come into the class and I'm going to start running this code, and it's going to say let's take H and W. But H and W don't make sense in the class. They make sense in an object. In an object, I construct a rectangle, I set the height equal to something, the width equal to something. H and W have values. But in the class definition itself, H and W don't have values. I have no way to give them values, because I'm just referring to the class itself, not an instance of it. And the compiler will know that, and it will say, hey, you're trying to do H and W aren't static. And so you think the compiler's helping you, and so now you go ahead and you add the keyword static in front of this, and suddenly this works. And now you try to do something where you you make an instance of rectangle, and you try to set the height and the width, and now you get warnings saying trying to make non-static reference to static fields. And so in your main program, you change your things to static, and so you start going down this static rabbit hole of changing everything in your program to say static, 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 and that's not what you want to be doing. And so the easiest way to avoid that is just don't use the word static, right? But there will be cases where we do need to use that. But if we put this keyword in here because we specifically want to make something like, you know, a static square root method, for example, then we won't get into trouble. And when I was learning Java, you know, I was just kind of like trial and erroring it, and I got all kinds of tangled up with this, and I'd be doing great. I'd be thinking, you know, I've got Java under control, and all of a sudden I'd do one thing, and I start getting the dreaded static error messages, you know, and I didn't understand what static meant. I just knew that sometimes it complained about it. So hopefully this tells you what it actually means, right? It's the question of a method that we access as part of an object versus part of the class itself. And so along those same lines, we can have static fields. So in the math class, there's a field called pi. And that's a double, but it's also a static. So if you want access to the value of pi, you can say math.pi.
How many digits is it to?
10 billion, 1,000, 100 million. No, I don't know.
20.
Yeah, it's whatever a double is.
Oh, is it actually to the length of a double?
Yeah, so it's a 64-bit IEEE 754 representation. So
Oh wow. You could just do it for like 30 digits.
that would be cool. They should have like a pi string that like prints it out to like 100 digits or something. All right, thanks for the confirmation on ODP 302. So ODP 302 is working successfully, and thanks for letting us know. All right, so this is accessing this field named pi as part of the class. So we don't have an instance of the math class, right? We're not saying, you know, math m equals new math and then m.pi, because we don't need an object. We don't need a particular math object. We just want the value of this field. And so it's set up as a static field. And so to use this, we can just do this. It's not a method, right? Math.pi is not a method. It's not something we pass an argument to and it executes. It's just a field. It's a variable. It's like myClass.x from ODP 301. It's just a good old double. And so to access it, we just say math.pi. And that will be a double, which when we concatenate to a string, we'll call the double's toString method and make it look like a reasonable string. And so that tells us pi equals. All right, so we can possibly venture into this question of public static void main. So why is this static? The idea is when I say Java smain, the JVM will do the following. If I say Java smain, the name of a class, it will call the name of the class dot main and put some arguments on it, whatever arguments happen to be on the line where I said Java S main. So the JVM makes a call to the main method inside the class S main. It does not create an instance of class S main. It calls it as a static method. And so we have to have that keyword static. Otherwise, when we try to say smain.main, we're making a static reference to a non-static method. And so I don't know which error message it will give us if we leave off static. The signature will match. But when it tries to run, it says the main method is not static. So that's how your main program runs when you say Java file class name. It uses class name to access that method. Well, that's a static access or a class method access. So it's got to be a static method. All right, that's all I have prepared to say on statics at this point. But if there's questions, we can dig into it further. But like I say, for the most part, you don't need to worry about it as long as you make your public static void main static, and you understand when you want to get to things like in the math library, if the documentation says it's static, you should run these things with the name of the class dot the name of the method. Or if you're trying to get to fields like pi or e, you should get to it through the name of the class dot the name of the field. And, you know, double is a class also. And double comes with some fields. Double.bytes tells you how many bytes are being used to represent a double. Double.max exponent, max value, min exponent, and so on. Positive infinity and negative infinity, and not a number. These are all fields you can access from the double class. And so we can do some weird things. I can say double dot infinity. I don't know if I got the uppercase, lowercase correct. Double dot, oh, positive infinity. Alright, so infinity equals infinity. So this is a valid double precision number. If you go back to engineering 250, 270, if you went through IEEE 754, there are representations for positive infinity, negative infinity, and for NaN, not a number. And there's special bit patterns in the 64 bits that make up a double precision float. And so in Java, we can access those bit patterns by using these static fields inside the double class. And we can say double dot positive infinity, negative infinity, not a number, and so on and so forth. Alright, let's do a 5-minute break. We'll come back. Let's play around with some linked lists. Let's put some linked lists together barehanded and see how that works. So we'll come back at 11:10. Alright, see you in about 5 minutes.
Hey, did anyone else get a thunderstorm complete with sleet yesterday?
Storm, but an absolutely insane amount of hail, which then turned into snow.
Yeah, It's kind of what I'm talking about, yeah.
Like I said, there wasn't any thunder. The weather's been all sorts of fucky.
Yeah. Yeah, I heard thunder though. I mean,
Oh, that's pretty cool.
yeah, there's a special weather statement that just said that there were like strong thunderstorms that I got like 5 minutes after I first heard thunder at like 2:30. I was like, oh, that's fun. But yeah, I thought it was pretty interesting because, oh, nice mystery. I thought it was pretty interesting because of the whole like tornado outbreak sort of thing that was going on in Iowa at the time, because there's like an enhanced, or no, more than enhanced risk of tornadoes yesterday there, so.
Interesting. Yeah, it killed all the power. Put like a ton of trees down around here. Apparently like 8,000 people were without power or something.
I got a couple of widowmaker branches down near my house, but like, my power flickered a bit, but like I didn't have it go out. Do you live in like Battleground or something, or what?
Yeah, it was about it.
Okay.
How do you know that, Sam? You checking my IP address?
No.
No, I'm just messing with you.
I know.
I couldn't
That's
get
all.
it.
I just took a random guess, okay? I don't know why I chose Battleground first. I just chose Battleground, okay? Okay?
Don't worry, it's fine.
All right, I'm back. So even though we have the benefit of, you know, all of these classes available to us, linked lists, hash maps, collections, all this stuff in Java, sometimes we may want to create data structures on our own like we've done in 222. And so I want to look at an example of that. Just as, you know, another opportunity to... we ended up being slammed with people. Interesting. Just as another opportunity to define some classes and think about breaking things into classes and working with classes and understanding objects and that kind of stuff. So this is not particularly topical to, you know, anything we're doing or have been doing. This is not part of PA1B. It's just some exercise in playing with classes. So let's remember how we do linked lists, right? We typically have these nodes, and there's two fields to them. There's a data field, and there's something that points to the next node in the list that we typically call next. And with linked lists, often we have a sentinel node, which is a special node that is always present and simply points to the first actual node of the list. And so I want to envision making a class on our own that gives us linked list capabilities. And we'll do this like the way we started with linked lists in winter term. We'll make a simplified linked list that will simply add things in the beginning and will remove things from the beginning, and we won't worry about keeping the list sorted and so on. So this will be kind of like, you know, a stack list. So I'm going to envision a class, and I'm going to call it, you know, my list. And I'm going to want some methods for this. I'm going to want a void add. I'll make this public. Which will let me add a number to the list. I'm going to want a Boolean search, which takes a number and tells me if that number is contained in the list. I'm not going to worry about deleting for now. And in 222 we had, you know, some kind of print, which would print out the contents of the list, maybe with like commas in between the elements or something. And so I want to envision making a Java class called myList that gives me access to these kinds of capabilities. So let's make a main program first of all. So this is a demonstration of the myList class. So what should we call our list? Somebody give me a name.
Listman.
Okay, call it listman. So myList listman equals new myList. All right, we're doing two things here. We are declaring this object to be an object of type myList, and we're calling the constructor. and we'll add some things to the list. And then we'll call our search method a few times, and we'll search for a 20, which should say good, and we'll search for a 30, which should say good, and then we'll search for a 25, and if that returns true, that's a problem. It should not find 25, so search should return false, and it should not say bad. And then let's go ahead and add a 25. And then let's repeat this search. And now it should find a 25. And then let's go ahead and print out our list. Alright, so this is just kind of a first order approach to using this list. So we're going to construct in the usual way. We're going to add some data. We're going to search for some data, add, search, and then finally print. All right, this is kind of a top-down mindset for the moment, right? So right now we're kind of thinking like, this is how I want to use this class. I want to be able to add and search and print and things like that. We haven't written any of this code. We haven't even written, anything about the MyList class. But we're thinking of it from a top-level perspective. What do we want this thing to do? Right? A genie bumps into us and says, "Hey, I'll write a class for you. What would you like it to do?" This is what we think about, right? And now we're going to move down to a lower level and think about, okay, so what should this class look like? So this is kind of top-down. And top-down is pretty typical for working with object-oriented languages, because ultimately the very lowest level steps are already written for us. We don't have to write something to compare two strings or change a string to uppercase. Those exist. We don't have to write something to take a string and hash it and store it with another string in an associative array. Those things exist for us. So objects kind of inherently make us think top-down. But we could do this bottom-up also. We could start with a node and then build a linked list and work our way up to the main program. But this approach we're taking here, this feels like top-down. So let's start building the MyList class. All right. Well, now I'm going to start with class and the name of the class MyList. And I'm going to use a Sentinel node. So this is going to be an object inside the class itself. I'm not going to declare the Sentinel in the constructor because then it's local to the constructor. So just like PA1B, I'm going to declare something in the class itself outside of my methods, which will be the Sentinel node. Alright, this is the Sentinel node for the list. But what kind of thing should this Sentinel node be? Well, logically, it's going to be a node. Well, what's a node? I don't know, but guess what? It's probably going to be a class. So I'm just going to call this a node. Well, what should our constructor do? Basically, all our constructor has to do is set the Sentinel node to point to null. So Sentinel.next, or Sentinel, it's got to construct the Sentinel. So I'll say Sentinel equals new node. and sentinel next will be null. And I'm going to set the data field of the sentinel to 1, 2, 3. We should never use the data field of the sentinel node. The only thing the sentinel node does is point to the first node of your list. So we're often going to look at sentinel.next, but we really never have a reason to do anything with sentinel.data. So what I'm doing is I'm putting a recognizable value into sentinel.data so that if I accidentally do something with it, I'll see this. If I run my main program and at some point it prints out 1, 2, 3, I immediately know, hey, you know, something is going on. I think I'm tinkering with the sentinel node, and I shouldn't be. So that's just, you know, kind of a safety thing that I'm setting up. And that's pretty much all that our constructor has to do. Basically create the new node, set sentinel equal to that, and then make it point to null, and maybe load a data field in. So let's add a number to the start of the list. Now if we were sorting our list, we'd move through and we'd find the first number bigger than what we're inserting. We'd back up and so on. We're going to do the lazier approach. And our add method is just going to add something to the beginning of the list. So this is public void add integer n. All right, well, go back to 222. How do we add something to the list? We've got a sentinel node. It's pointing to something. We're going to make a new node. We're going to store our data in there. We're going to have our new node point wherever the sentinel is pointing, and then we're going to change the sentinel to point to our new node. So if our sentinel is pointing at a 5, which is pointing at a 10, and we're saying, you know, add a 20, we're going to create a new node. We're going to set the data to 20. We're going to point to what the sentinel is pointing to, and then have the sentinel point to our new node. So now our sentinel points to a 20, which points to a 5, which points to a 10. Well, we need a new node, so let's make a node new node equals new node. So this is the new node for the list. And our new node's data field should be set equal to the number we want to store. So we're going to point to whatever the sentinel is pointing to. And then have the sentinel point to us. And that's probably all we need. So create a new node, store our number n in the data field, have the next field be whatever the sentinel is pointing to, and have the sentinel point to us. And sentinel nodes are your friend. They make this work without a whole lot of special cases. So here's what could be a special case. An empty linked list. You have a sentinel node that's pointing to null. Well, what does our code say? It says make a new node. It says set the data field equal to n. So this is, you know, whatever number we're trying to add to our list. Have the new node next set equal to sentinel next. Well, sentinel next is null, so that will set this equal to null. And then finally have the sentinel next point to the new node. So now our sentinel points to this. That's exactly what we wanted to have happen. We started with an empty list, we created a new node, our sentinel points to that, and the new node points to null. So because in an empty list, sentinel next is null, this automatically makes new node next equal to null if our list was empty. So this works great. So let's see if the list contains a number. So we'll make our search method. So we'll return true if we find our number in the list. I'm transposing like a beast today. So we're just going to start at the beginning with the first node and move down the list and look for our number n. So we're going to need a temporary pointer. I'm going to call it temp. I'm going to set temp equal to sentinel.next. Alright, so here's our sentinel. And this is pointing to the first node of our list, to the second node, and so on, to the last node. So I'm going to make a temporary node called temp. I'm going to set it equal to sentinel next. So temp is going to look at the first actual data node in the list. Or it could be null. If our list is empty, sentinel will point to null, temp will be null. If temp comes all the way down here and we've checked this last node and didn't find the number we're looking for, at the bottom of our loop we're going to say temp equals temp next. In that case, temp will be null. So just like in 222, we're going to want to loop as long as temp is not null. So we're looking at a node temp. Let's see if that thing has the data value we're looking for. So if temp.data equals n, we can return true. Otherwise, what do? Temp equals temp.next. So we move to the next node, or possibly to null if we're at the end of the list. If we come all the way down here and we exit our while loop, it means that we moved down the list until we got to the thing the last node was pointing to, which was null, and we never did our return. That means we did not find our number, so we can return false. So there's our search method. I don't want to write the print method yet, so I'm just going to make that an empty method. So let's compile our list main. Hey, 5 errors, that's not too bad. So what's the problem here? Go to your first error message. mylist.java line 2 cannot find symbol node sentinel. Make your screen wide enough. And it's pointing to the word node. So the compiler is telling us it does not know what this symbol NODE is referring to. Why not? Well, because we never said what an NODE is. Right? So here's list main, and we create a mylist, and in the mylist class we have this sentinel, which is a node. It doesn't know what a node is. Well, a node is a class that we just haven't defined yet. So let's make a node class. So node.java. So there's a data field, which is an integer. There's a next field, which is what? It's a node. There's our node class. So this is one node of the linked list. And this could look bizarre because we have a node that contains a node. But think back to 222. When we defined a node, what we had was a pointer to a node. So this is not actually, a node embedded inside a node, and that node has another node embedded inside of it. These are references, right? But those details are cleared from our view, right? We just think of a node as something that contains an integer and another node. And so this is, the simplest class we could imagine for a linked list node. And so let's see where we get if we compile this. Amazing. Alright, so let's go ahead and run this. And it said, good, good, good. Alright, so those first two goods were because it found a 20 and a 30. It did not find a 25, and then we added a 25. Searched again, and it said good, exclamation mark. So apparently our add and search methods are working correctly. But of course the real money is, let's go ahead and try to print the contents of the list and see what we get. We are down to 9 people in the class. This is good stuff though, so. Alright, let's make our print method. Well, how do we print linked lists in 222? Start with the thing the sentinel points to. If it's not null, print out the data field, go down to the next node. If it's not null, print out the data field, go down to the next node. Keep doing that. Alright, so let's do that here. So we'll have a temporary node, which we initialize to the sentinel. And when I'm doing this, right, I'm not passing anything to print. I'm just saying, mylist.print. So what sentinel node is it getting to? This sentinel node. Where did this sentinel node come from? It was constructed when we called the constructor for the list. And so if I have a list called listman, when I say listman.print, it's looking at the sentinel inside listman. So this is the first data node in the list, or possibly it's null. So while temp is not equal to null, so let's print out temp.data plus a comma. Let's move temp to the next node. Let's print a new line, and we're good to go. So for each node in the list, we'll print out the data value plus an annoying comma and move to the next node. So compile that. I knew I'd do something wrong. Alright, so we'll print out the data value plus a comma. So there's your list. And we're inserting the beginning, so this is acting like a stack. So we added 10, 20, 30, and 25. There's a 10, 20, 30, and 25. And we've got our data. Holy cow, tailing again. I'm waiting for frogs to start falling from the sky. This is pretty awesome. How's that look? Oh, I got the pukey cam action going. But yeah, that's legitimate hail.
There's a really huge one right there on the lawn.
That is a huge one, yeah.
Really giant hailstone.
Yep. Oh, I killed my camera. Oh, there we go. Got me rubbing my face. All right. So let's clean this up a little bit. Yeah, my camera's.
Video camera is a slideshow for me.
Yeah, that
Frozen, actually.
that just like froze, so I'm just gonna close that because it doesn't want to work today. All right, so so two cleanups we want to do on this, and then we'll do some more embellishments. First thing is this annoying comma, right? This is always kind of a thorn in the side for people. Sometimes, you know, we get that trailing comma at the end, or we just use spaces so we don't have to deal with commas. I've had students who print out a backspace followed by a space at the end of the list to erase it from the screen, and things like that. So let's get serious with this. You want to print a comma-separated list of numbers, right? Well, one way to do that is to print the comma before each number, right? So that there's no comma at the end. So we can do this. And at first this looks, you know, only marginally better because we have a straight comma in the beginning now. But that's actually a lot easier to deal with because we know when we're printing the first number in the list. Why? Because it's the first time that we're executing that print statement. So here's one way to do this. Let's just make a flag called do comma, and we'll initialize it to false. So if do comma, we'll go ahead and print a comma. We won't print a comma down here. And after the first time that we print a number, we'll set do comma equal to true. Alright, so do comma is false, which means the first time that we print a number, we won't print the comma. We'll print out the number itself, but then we'll set do comma true. So if we're going to print a second number, we'll print a comma before it, and so on and so forth. So now if I run this glorious output, my numbers with commas in between and no straight comma in the start or the end. So that's just, you know, some programming. There's nothing magic or Java specific about that. All right, well, this works, and this is, you know, on par with what we did in 222, but this is not quite optimal. Because this print method does what? It always prints to standard out. Anytime I call print, it sends this nice representation of my list to standard out. And sometimes that's exactly what you want to have happen, but sometimes that's not. Maybe I want to take the contents of the list and save it in a file. Or maybe I want to do something with it. Maybe I want to convert the strings in my list to uppercase. And so what could I do instead of having a print method that just takes the contents of the list and sends it to standard out? What other kind of method could I possibly write that might be more useful? So alternatives to the print method. Any suggestions?
We would make a toString.
Yeah.
toString method.
Let's make a toString method. toString is much more useful than print. Because what does it do? It returns a string representation of my list. And if I just want to print my list, well, I can just print that string using println. But if I want to do something like, convert it to uppercase or lowercase or save it in a file or send it to somebody on a network, I can do that because I have that stuff inside a string. So instead of a print method, it's going to be more useful generally to make a toString method.
And just to be clear, if a function or if a method is called toString, that will be universally recognized by the JV.
As long as it's called toString, it's public and it returns a string and it takes no arguments. So as long as it has that exact signature, yes, it will be recognized anytime you try to concatenate or change your object into a string. Alright, so we're going to leave the print method in here. And I'm going to call this the obsolete print method. This is the more useful toString method. So here's my public string toString. Alright, well, it's going to do basically the same stuff, except these prints, instead of printing to standard out, we're going to concatenate to a string that we're building up. So let me make a string return me, and I'll initialize to just an empty string. And this is going to be the return value from our method. And so instead of printing a comma, we'll just concatenate a comma to our string that we're building up. And instead of printing temp.data, we're just going to go ahead and concatenate temp.data to our string. And we don't need a new line at the end. In fact, we don't want a new line at the end. But what we want to do at the end is return this string that we've built. And so there's the toString method. And it's almost exactly like the print method. But instead of sending our output to standard out, we're tacking it onto a string that we're building. And then we're going to return that string at the end. So that still compiles, that's good. Let's go ahead and change our list main. And just use a plain old print line method. List man. So we'll just say your list is, and we'll just concatenate this with a plus sign. And that should cause listman.toString to be called, and the string that comes back will get concatenated to the string your list is, and we should get your list is, nice comma separated list of variables. Alright, you ready? There you go. So there's your list. All right, good so far. All right, so let's keep pushing the idea of objects. And let's make a new version of this. So I'm saving the old version under V1 because I'll push the code to the server for reference. But let's make a new version of this MyList class. And one thing we can do is note that when we create a Sentinel node, we usually want to do something with the fields in there. Down here we create a new Sentinel node when we say add, and we have to set the data field equal to something, and the next field equal to something. And sometimes we want to set the next field equal to null. And so we can start to embellish our node class. So let me save this in a version 1. All right, so we can make a constructor. Public node. And what should we do in our constructor? Let's just set next equal to null. Let's give a value to our next field. And now, when I construct a MyList, I don't need to say sentinel.next equals null, because I know when I construct a node, by default now, the next field is going to be equal to null. So all I have to do is set the data value equal to 123.
Can you set the sentinel data 123 to the init constructor?
I could. I'm going to do something a little different though. I'm going to make a second constructor that lets me specify a data field. And here I'm going to set data equal to n, and I'm going to set next equal to null. So this is my default constructor. And this is going to let me construct with a data value. So now down here, I could have simply said sentinel equals new node 123. And now I've got a one-line constructor for my list. And down here, when I say node, new node equals new node, I can just pass n right here as an argument. And it's going to construct my node. It's going to set the data field equal to n. It's going to set next to null. That's okay, because I'm going to come in here and I'm going to change next to be what I want it to be. But that's just a little bit cleaner. And I'm going to test my code as I'm making these changes. In fact, I should have tested it after that first change. If you have code that works and now you're trying to add something to it or embellish it in some way, it's generally really useful to keep testing it along the way. Now, if you have to write 2 hours of code before it's usable, that's a different situation. But if I'm making changes to my code, if I'm adding things one at a time or improving things one at a time, I can keep checking as I'm doing that. And if I mess something up, if I have a brain blip and I start forgetting to use the word new, for example, I don't want to get 100 compile errors because I wrote, 100 statements where I should have had new and I forgot to put it in. I'm going to test my code as I expand it, as I continue to develop it. And if I had gotten a compile error here or an exception when I ran it here, I have a really small set of code that changed that I need to dig into. Right? So this is just trying to save myself work down the road. Because I'm going to make mistakes. I'm going to do things that aren't what I think they are. And I'd like to know when that happens rather than, you know, at the end of a marathon 12-hour coding session, I try to compile my code for the first time and there's 1,000 errors. So I'll keep doing this as we go. So our code still works. What else could I do to embellish my node class? If I just wanted to kind of like go overboard and make my node class even fancier. Any suggestions? Could I make a new constructor? A lot of times when I create a node, I want to specify both a data value and a value for the next field. And so I could make a even fancier constructor where I specify both the data and next fields. So I could do that. So now I've got a constructor that takes two arguments, an integer and a node. It sets the data field equal to the integer. It sets the next field equal to that node. What does this let me do? It lets me down here when I construct my new node for my add method. Construct a new node with a data field of n and a next field of sentinel.next. And now my add method is 2 lines. And it's not just that fewer lines is better. Sometimes fewer lines is worse. But this one statement tells me everything that I want to do in here. I want to create a new node with a data value of n, and I want that new node to point to what the sentinel is pointing to. And then I want to change my sentinel to point to that new node. Well, those are the 2 steps that we use when we add something to the beginning of a list. Right? Create a new node that points to where the sentinel points and have the sentinel point to the new node. So my code is now more closely reflecting my thinking about how I want to do this operation of add a new number to the start of the list. And this is another thing that you're generally looking for when you write code. You want your code to be in harmony with your mindset, with what you're thinking about doing. When you go back and you look at your code, you should not have to scratch your head and reinvent the wheel to understand how your code does something that you asked it to do. Ideally, the code you've written more or less explicitly describes what you were thinking you wanted to have happen. Create a new node with this data value in this next field, and then have the sentinel point to that. Alright, and I made a typo. Well, that was unexpected. Node int and node next field. Okay. I don't know what I typoed here, but let's look at it. So list main line 7 is calling the add method. The add method line 12 is throwing an exception. So let's look at my list. Let's go to line 12. And it's calling n and sentinel.next.
Is it saying that you don't have a constructor for that specific situation where you have two inputs?
Yeah, so I think the problem is I modified the node class at 1155, but my class file is from 1149. So this is a cautionary tale, right? A lot of times when you compile, say, your main class file with your main program in it, it will compile other .java files that it needs, but it doesn't always do that. For example, it recompiled the my list, right, to make the latest list main, but it did not recompile the node class. So make sure you don't chase specters. Make sure that if you change a method, like I changed the node class, go ahead and recompile that. And then life is good. So we can get kind of lazy sometimes, and you know, if I change the my list class, I might just recompile list main, and that'll recompile my list for me. But your safest bet is when you change, you know, blah.java, recompile blah.java. And so I actually still use makefiles with Java code for bigger projects where I have lots of different classes and such. Or, you know, Java C star.java if you want to be really lazy and you're working in a contained directory and so on. All right, so this still works great, right? And so there's a simplified constructor that lets me specify both the data and the next field. And so my code gets a little cleaner. All right, what about public and private? Right now, the main program that I've written has access to the Sentinel node because the Sentinel node is not marked as private. What happens if I make this private? That should still work fine. It works fine because I obeyed this firewall between like the caller and the implementation of the data structure. Nowhere in here do I mention the word Sentinel. And that's important. Right? If I don't make Sentinel private, I could theoretically say listman.sentinel equals such and such. And I could corrupt or change or modify or tinker with my linked list, right? But I can mark Sentinel private, and if I try to do something like that, I'll get compile errors in here. So this is looking like a pretty solid linked list implementation now. It's got a Sentinel node. The Sentinel node has restricted access. Private var cannot be read, so it's no read, no write. And I don't think there's a way to make something that's readable but not writable using this mechanism.
You know, there's another type of thing called a protected part.
So protected means that in this case, everything in this directory would have access to it. So it's what's called a package level protection. We haven't talked about packages yet, but a package is basically all the stuff in my current directory. So in this case, list main, my list, and node are all part of the same package. So if I make these protected, everything can access everything. And protected is the default if I don't say public or private. If I make it private, then only things in this class can get to it. And that's good, because it's only things in this class that need access to the Sentinel node. For example, to construct it, or to use it to add something to the list, or to iterate through the list, to search or print or whatever we're going to do. All right, now we can get more and more draconian. And if we really kind of think about, you know, restricting access to things within the class that are supposed to access it, right? We're encapsulating, right? We're putting code and data together. So here's a class called node. It contains some data, right? These two fields. It's got some constructors. And we could put, you know, things in here that should interact with that data. And in a pure kind of encapsulation mindset, nothing outside of this class should be able to tinker with these things. So ideally, we could make this thing private. So our data field is not accessible from outside. So if I compile node.java and I try to run list main, I'm going to get an error. Okay, where's the error coming from? Line 23 of mylist.java. That's right here, if temp.data equals n. Well, why is that an illegal access? Because temp.data is marked private. And so while I'm running this, it says try to access the field node.data, and I got an illegal access error. It's a protected field. So how could I make this field private but still allow access to it? I could make an accessor. So now I've got a method that I can call getData, and it'll return the value of this private field. I just have to make sure I use that everywhere, and so instead of saying temp.data, I'm going to say temp.getData and call it as a method.
So like it's kind of like you're like opening access to the main program to manipulate it, right?
Mm-hmm, exactly.
Okay.
So I can compile my node class. I forgot to say that it returns an int. I'll compile the mylist. Well, here I'm getting a compile error. And again, it's the same kind of thing. Data has private access inside a node. I can't say temp.data because it's private. So in addition to doing it there, I need to do it down here. And one more spot. Alright, this is going to work better. Oh, it actually worked. Okay. Yeah, okay, because the add method's fine. Alright.
That's a pleasant surprise.
Yeah, right. I mean, I knew it was going to work. So we've got protected access to the data field in a node, but we can still read it by saying get data. And when we call the add method, well, the add method has access to it. Actually, yeah. So the add method does not say, you know, node.data equals n the way it used to, because we specify the data field in the constructor. And in the node class, right, the constructor says data equals n, but the constructor is in the same class as data, so it has access to it, even though it's private. So this is nicely firewalled, right? The node class, the only thing that can tinker with data is stuff inside here. The mylist class, the only stuff that can tinker with Sentinel is stuff inside here. So let's push it a little. Let's make the next field private also. Right, so now I'm getting errors from my list because it's trying to tinker with this private field. So let's go back to my list, line 12. That's weird, it threw it at line 12. Anyway, so this is a problem here, right? We're trying to change the next field of the Sentinel node. And we've said that next is a private field. So what do? We make a mutate. Say again?
I think it's line 12 because you're trying to pass or use the send of next when passing or recalling a method. I think.
Oh, right. Thank you. All right,
Yeah.
so we've got this problem here. So let's add an accessor, and while we're here, let's add a mutator. So that we can get the value of the Sentinel's next node with the accessor, and down here we can change the Sentinel's next field with a mutator. And down here we'll use get next. And down here we'll use an accessor. Or we're gonna have to change all of these. What a pain. You got 4 minutes left. I'll start it in the code. All right, in the words of Yul Brynner. Get next, we'll just return the next field as a node, and so on and so forth. So, I won't finish that up because we need to change a lot more code, but you need to set a mutator also, which would take a node and set next equal to that node, and then in here use those get node, or get next and set next methods. And then you've got a nice clean abstract data type. All right, so that's an example of a manually constructed linked list. So Monday we will talk about PA2. So I'll get that together and post it over the weekend, and we'll start in on that. We'll probably have another ODP Monday. And then I want to talk a little about generics and look at how we could modify this linked list package to work with strings or rectangles or other things, and how we can define our own generic class that takes a parameter to specify the types of things inside it. So we'll play with that next week. I have office hours Thursday and Friday mornings. Come by if you're stuck on things or want to go over anything. Otherwise, have a great rest of the week, a great weekend, and I will see everybody on Monday. All right, thanks.
Happy Easter.
Oh yeah, happy Easter.
Sunday.